Well, good morning, scientists. It's Sunday morning in Mr. Bosco's lab/shop. What I want you to be doing today on Monday is in your journal, in your journals, I want you to create a journal entry for page 10. And you should write it as observing a chemical reaction, like it says up there. Observing a chemical reaction in here for October 5th, 10/5/20. Okay, do that now. And then turn to page 10, and I want you to write what you see up there. Observing a chemical reaction. And then I want you to put this is called a up here. This is called a chemical formula. And I need you to write it exactly as you see it. So in a moment, you're going to pause the video. And when you see, if you see a capital letter, make it a capital letter. If you see a lowercase letter, it's important that you make it a lowercase letter. So if you look up there, you'll see NaHCO3. Na, capital N, little a. Okay, when you see the numbers, notice there are little numbers that are down low. Make sure you do that. Pause the video now and put this in your journal on page 10. Create that table of contents entry. Go. Okay. Hopefully you're back now, right? I gave you some time. And here's what we're going to do. We are looking at chemical reactions today. And when we look at chemical reactions, what it is, it's when we actually mix two different types of substances. Actually, it doesn't even have to be two, it could be one. We can mix three, we can mix five. In this case, we're going to be mixing two molecules together, many of them, but two different types of substances together to make a reaction. Many of you have probably done this reaction. I don't know if you can tell by what's above my head here, but what this is baking soda and vinegar. Yeah, but these are the molecules up here. Those are the molecules that represent baking soda and vinegar. All right? All right, so you should have that all written down. I'm going to make my head smaller now. And because I don't want me to be a distraction to you. And what we're going to do next is okay. In your journal, now you're going to have to kind of make this a little small because you need to fit all of this on one page. Remember, we're staying on page 10. Okay, so when you have that written up there, one thing I want you to do is you are going to note this as these are molecule. That's a molecule. Okay, that just happens to be a molecule of baking soda. This is what baking soda is made up of. Baking soda. Okay, and then this one here, guess what this is? Yes, this one too is a molecule. Okay, that's a molecule of what we call vinegar. Vinegar. Okay. All right. So, but before we do to get into these observations of a chemical reaction where we're mixing one substance, baking soda, and another substance, vinegar, we need to do some vocabulary. All right. So here's the first two are going to be a review. First two are going to be a review. Let's put a little ziggly line here. Ziggly line, right, like that. So we separate those. And we're going to write down here, we're going to write vocabulary. Because to do this lesson, I need you to know, whoops, I need a Y. I need you to know some of these scientific terms, okay? But first off, let's talk about observation. We already covered observation a little bit. Observation, right? And one thing I'm going to have to do is lower my screen a little. Let's lower that so you guys can see a little bit better. Observation, and we decided that was to pay close attention oh, my handwriting is terrible, to something, right? That's really it. To something. And what did we use? We used our senses. You can use any one or more of your 5 senses, right? To pay close attention to something. The second thing we learned was the word inference. Inference. Now, you should be taking these notes in your journal as well, okay? An inference is to make a best guess. Make a best guess, or you might say an educated guess, based on something or things you observed. Okay? Uh-oh. To make a best guess based on something or some things you observe. That's what an inference is. Okay, we learned all that last week. Here's some new words for us. I'm going to scooch our screen down. I don't know. And so we're going to have to try to fit these in here. Don't write too big. And the next one's going to be chemical reaction. Hopefully you're doing this on page 10 on the right side, right? Oh, my word. Let's spell this correctly first. Chemical reaction. Okay, what's a chemical reaction? Basically, a chemical reaction is a process. A process where one or more substances a substance is just a pile of stuff, or if it's liquid, it's a pool of stuff, okay? One or more substances change into different substances. Substances. Okay? A process where one or more substances change into different substances. When you see a firecracker blowing up, basically what's happening is a chemical reaction. Some molecules, which are sitting there safely, we add heat to it, and they change into something else, which allows it to be explosive. Okay? Chemical reaction. Okay, briefly, we're going to cover 2 different types of chemical reactions. We're going to look at one type, and we're going to call this, here's a big science word, endothermic. Thermic, that sounds like thermal. Something to do with heat or energy. Endothermic is where energy is used. Energy, and I'm going to put in parentheses, heat is used. Okay, and I'm going to write in parentheses here, gets cold. Okay? All right. So if you need, pause this video and just keep getting this stuff down. Another one is called exothermic. Okay, we're going to start using these terms when we're talking about chemical reactions. Okay, and this is an exothermic reaction is when energy or heat, could be in the form of heat often, is released during the reaction. Whoop. I'm going to get rid of that. Released. I actually write a little bit neater when I'm not writing on this little pad thing. And this means gets, what do you think? Yeah, it gets hot. Good. Okay, so hopefully you got that stuff down. I often like to go back and underline my important words. Okay, underline those important words: chemical reaction, inference, and observation. Because you're going to use these notes. I want you to go back to these notes and read these instructions. Okay, so I'm going to move this up a little bit for you. And I want you to take time, and I mean, probably a good idea to pause the video, make sure you have these down. Notice I put spaces between things. Keep the spacing in there so that you can easily find this information. Okay? All right. Pause the video, get those vocabulary down, read over them a couple times. Observation, pay close attention to something. Inference, to make a best guess based on something you observed. So far, so good? Good. Chemical reaction is a process where one or more substances, or chemicals, change into different substances, or chemicals. Endothermic is energy, which could be in the form of heat, is used, and the thing that we're doing, that reaction, gets cold. Exothermic is energy, that heat, is released by the reaction, and the reaction will get hot. We're going to actually see one of these, endothermic or exothermic, when we do this reaction. So put the video on pause, and I'll be right back after I set up our demonstration. Okay, now I've got our lab set up over here. And something we have to do first, though, every scientific experiment needs to begin with some observation, because you don't know what to experiment for unless you observe something. All right, so we're gonna first take a look at the two chemicals that we are going to be using in our experiment. And if you ask your parents and see if they'll let you take a look at some vinegar and some baking soda. Now remember, this is kind of a messy experiment, so make sure you lay out something if you're going to be doing this along with me. All right? Okay, so first thing we're going to be looking at is vinegar. Vinegar. It's also called acetic acid. Okay, it's an acid, not a very strong acid. It's not going to burn your fingers off. But if you put some on your tongue, because it's safe, it's vinegar. If you put some on your tongue, you'll feel it kind of tingle. That's because it's a light acid. Okay? All right. So what I'm going to do is I have some vinegar in what's called a petri dish. I just poured some in there, and we're going to do some observation. So on your notes, or in your notes, on page 9, like I have, up there, page 9, make sure you title it again, Observing a Chemical Reaction. On page 9, you are going to write the following. I'm going to move my face out of the way, and I want you to just kind of put this down. Pause the video and write this out. Observations: baking soda, in parentheses, NaHCO3, which is the chemical formula for baking soda, and put a little dot there because we're going to take some observations. We won't have very many. So just one line, skip a line. Vinegar, HC2H3O2 is its chemical formula, and put a dot. Okay, a bullet point. And then pause the video, do that right now, and come back. Okay, so hopefully you're back now. And what I'm going to do now is to take my petri dish, which has a little bit of vinegar in it, and we're going to look at it under the dissecting scope. All right, so what I'll hide, I'm going to make my face a little smaller because I'm not that important right now. And we're going to show, here is, again, underneath, I'll put my finger under here. This is our dissecting scope. And right now, all you do is you see the bottom of the scope, and I'll focus it in a little bit. And so notice you see those little dotty little texture of the bottom of the scope. You're going to see that through the petri dish. I'm going to put the petri dish under here, and I'll put it on the edge of the vinegar, and I'm going to focus it in, and we're just going to observe it. Really, what is there to observe here? We're looking at the vinegar. To me, if I was to write any kind of observations, I would say it's clear. You can see the little dots of the bottom of our dissecting scope underneath it. It's a liquid. If I move it, you can see it's kind of moving around. In fact, I'll take my forceps and I can put them in here and I can move it around. It's a liquid. There's some bubbles that showed up when I put the forceps in there. So clear, it's a liquid. It's colorless. There's no color. It's totally transparent. And if I was to smell it, I'll pull it out of here. If I was to smell it, which I hope you will at home, if you're trying this at home, if I smell it, it's kind of a bitter smell, right? It's kind of bitter smelling. And that's the acidity in that liquid. So let's put this away. Let's do this. And I am going to write, under vinegar, we decided that we saw that it was a liquid. It's a liquid, yep. It's a liquid. What else did we think? We thought it was clear, right? Clear. And there was no color. So let's write colorless. You guys are doing some real science now, folks. And when we smelled it, it was a bitter smell. Bitter smell. If you come up with a better term than that, use it, okay? I couldn't think of anything other than bitter. But typically we don't take chemicals and put them in our mouth. In fact, hardly, never, okay? In our classes, we will never do that. So vinegar, we know that it's a food product. You don't want to drink vinegar. But if you were to taste it a little bit, please don't. If you were to taste a little bit, it would kind of be tangy on your tongue. It would make your tongue kind of fizz, right? Not fizz, it would make it burn a little bit maybe, right? Because it's a little light acid. Okay, next, we are going to take a look at baking soda. Here's baking soda. NaHCO3 is the chemical formula for baking soda. You can see that. So if we were to look at this just through the Petri dish, we would probably tell ourselves, in fact, let me make this a little bit bigger. Make it bigger. And if you were to look at that, and I put my finger in here, move it around a little bit, you notice how powdery it is, right? It's powdery. Does it have a color? Kind of has a color. It's white, right? It's white. So we have a white powder. If you were to take your finger, if you have some baking soda at home and you're trying this, put it in your finger and kind of move it around. Again, normally, I'm going to say safety, when we're doing chemical experiments in a lab, we want to have gloves on. But I'm using safe chemicals for you because, you know, we can put these in food, you put these in cake. You can use your fingers without gloves on these, all right? We're not going to do anything at home that I feel is unsafe. So put your fingers, rub them around. What does that feel like? How would you describe that? I would describe it as gritty. It feels like grit between my fingers. In case you don't have any baking soda, to try this. Okay, so on my notes, you can see the notes there. I am going to write white. It's got a white color, white. I might write powdery, because it was like powder, right? And if I flicked it when it was on an angle, it kind of fell down. And then also gritty. But let's look at it under the dissecting scope and see if we see something different. Let's go to our dissecting scope, make my picture a little bit smaller. And I'm going to take our Petri dish and I'm going to slide it into the dissecting scope. It's always good to look at them on the edge. That's where you see most of the details. And I'm going to focus it in a little bit here. Try to make it a little bit bigger for you to see. And try to get it focused better. Okay, we have it on 2 times the normal size. So we're looking at it twice the size that it normally is. And one thing I'm noticing on here is moving my mouse here. You notice this? It looks like little crystals. They look like little crystals. It's not so powdery when you look up close. Little crystals, almost you see sharp edges on them. If you can look at this one, you can see sharp edges, and they're definitely transparent, meaning you can see through them. And I'm going to switch the dissecting scope to 4 times the normal size. Maybe. There it is. 4 times, focus it in. Now we can see it a little bit bigger. And what do you notice? It doesn't look so powdery anymore. It looks almost like sand on the beach. So you can, if we're going to look at these under the microscope, or if we're going to continue our observations, something you might write, I'm going to put a little dot here. I should have made this, I should have skipped some more lines, but I didn't. So you can say that they look crystal-like, and actually they are a crystal. Sharp edges, okay? And if you can see anything else on there that you would like to put in, add that to your notes. Pause the video. I'll try to keep this. And if you have more you want to show or you want to observe, put it down in your paper. The more you have, the better your science will be. Okay? Pause the video. All right, scientists, here we are. I want to give you a little show and tell on what I have set up in our lab. On the left, right here, we have a meter that is going to be reading through this little wire the temperature of our reaction as it occurs. Right now, it's reading 18 degrees Celsius in the air. If I put my finger over it, you'll see that it starts increasing because my body temperature is rising it to 31 degrees Celsius. I have my coffee here, which isn't very hot anymore, but if I put this in here, it's going to rise to 53. So my coffee's a little bit warmer than I am, right? All right, I'm going to take that out, clean my probe off. I'm going to set my probe in the beaker. I'll try to get it to set in the beaker. At the bottom of the beaker, this beaker is going to be my mixing vessel. I'm going to be mixing the chemicals together in here. In this small beaker, I have 75, a little bit more than 75 milliliters of vinegar. If you want to do this at home, it's about 1/3 cup, okay? And you can just put this into a regular a large kind of maybe mixing bowl. All right, I'm going to pour it in here and make sure that my probe is in the solution, which it's not. It's having a little tough time with me today, right now. I'm going to make sure it's in the solution, and we're going to see that it's 18 degrees Celsius. So in your notes, remember we wrote before the reaction temperature, and we had to underline a space for the temperature of the reaction before. So we're going to write 18 degrees Celsius for that. Okay, in your notes, put 18 degrees for before the reaction. Here I have 15 milliliters of baking soda. That's 1 tablespoon, all right? Science uses metric, but we're going to use 1 tablespoon in case you want to try this at home. Remember, this is a very messy experiment. Make sure you lay something down. I've laid cardboard down. You might want to lay a towel down, okay? Or something that's going to collect your spill if this spills over. All right, so when I put the baking soda in with the vinegar, a reaction is going to take place. The baking soda, the molecules and atoms within that baking are going to fall apart. The molecules and atoms within the vinegar are going to fall apart. They're going to mix together and make new molecules, new chemicals. All right, that's what a reaction really is. We're going to try to figure out, is this an exothermic reaction or an endothermic reaction? Look at your notes before you start. Endothermic is energy is used up, making the solution get colder. Exothermic means the energy is released, making the reaction hotter. Okay, the ending solution is going to get hotter. So let's figure that out. Right now it's 18 degrees. We're gonna add the baking soda to the vessel, the beaker, and I want you to do two things. Note the temperature change is one. Two, I want you to look at the reaction as it's taking place and take observations in your notes. Write those down. What are you noticing is happening? Okay, here we go. Notice the temperature, 18 degrees, right? And I'm going to put the baking soda into the vessel. What's happening with the temperature? As the reaction takes place, we're noticing something change in the temperature. We're noticing something going on in the beaker. And what just happened? I want you to make observations. Maybe repeat the video. Write down as much as you can in the after the reaction section of your notes. What happened? What was the temperature change? What did it go to? I think it looks like it's 13 degrees now. Write 13 degrees in there. And something else, instead of just 13 degrees, maybe subtract the observations before and after. Did the temperature go up? And if so, how much? Did it go down? If so, how much? Write all those observations down. Notice what's happening now. How long did that reaction last? All of this stuff is important information to put into your notes. So do that now, and we'll have a discussion next. Okay, folks, so we just did our experiment, and you were to put some observations into your notes. So you should have done that. I'm going to go over what I would have expected you to write down, just so you have some things in your notes. One thing we noticed was that before the reaction took place, we had, what was the temperature? It was 18 degrees Celsius, right? After we added the baking soda to the vinegar and the reaction took place, the temperature dropped to 13 degrees. And we watched that happen. So you got to be thinking, is this an endothermic or an exothermic reaction? If you're thinking endothermic, you are correct, because the temperature was used up in that reaction. It used the energy from its surroundings to make that reaction take place and drop the temperature of the solution in the beaker. So it's an endothermic reaction. So down here on the after the reaction, oh boy, I'm going to move it down a little bit. After the reaction, we found that this was an endothermic. That was an observation. Endothermic reaction. Normally, I give myself a lot more room for these observations, but for this one, we're just doing a trial. We're just kind of looking at this. We're going to go into more detail on this later. What else did we notice? I noticed, I'm sure, I hope you did, bubbles formed in the beaker, right? Didn't you see bubbles rise up? It was kind of hard to tell from the video, I know, but bubbles rose up. Let's see, lasted, and notice I'm not doing complete sentences. These are just notes. These are notes for me. Lasted only a few seconds. And then the bubbles went away, right? Where'd it go? Where'd it go? Right there. Before bubbles disappeared. Right? Let's see. Up here, because we know it's an endothermic reaction, one thing I also noticed was that the temperature dropped. Let's see, 18 minus 13 equals 5 degrees Celsius, right? The temperature dropped 5 degrees Celsius. That's interesting. Now, I always put a place for inferences in my observations because a lot of times we make inferences as we're observing things. And if we're going to make an inference, let's write them down. They're not an observation, but there's something that's important because it might make us think, maybe I can test this as an experiment to learn something new. So one inference I thought of as we were doing this, one of those inferences was that the reaction seemed, oh boy, let's do this. Let's get rid of all that. The reaction seemed, I just want to put a D in there, seemed to form a gas, right? It seemed to. We got bubbles. Isn't that what would form a bubble? Is some kind of gas? We haven't talked about gases, but let's just say that. A second inference I had, you might have had other ones, is that I think I'm going to kind of improv or shorthand this. Temp dropped, small amount, because not enough baking soda. That was an inference. I noticed that as I did it. I was thinking, I wonder if I added more baking soda, would it increase or decrease the temperature more? Would it have caused more bubbles? I just kind of made that inference and thought, I should probably write that down. But there's many other inferences you could have made about this. And if you have those down, don't erase them because those are your inferences. This is going to move us into questioning, because questioning is the second step of the scientific method and the process that scientists use to solve natural mysteries. Okay, so I think that's probably good enough for now. And we'll probably continue this next week, or we'll be working on this through the week. If you've done all this work, you're ahead of the game. And now you can actually be thinking of other things, other kind of experiments that you can do with baking soda and vinegar at home. But make sure you check with your parents. Check with your parents. Check with your parents. Always be safe. Okay? That's all I got.